All right, proportional relationships. First of all, I have to define what is a proportion. The best way to describe it that's non-mathy is to say it's two ratios that are equal to each other. Now, there is this thing called a proportion equation that you're going to have to get used to. I'm going to write this down. Do not freak out. Y is equal to kx. I know you're looking at it and going, what is that? You know, you're at the point now where we're going to be dealing with equations all year, so we got to get used to this. Let's think about it. If I said it's two ratios that are equal to each other, and I have three variables in this equation, then two of them have to be your ratios. In fact, this one here is a ratio, and the x value here is a ratio. So then you're saying, all right, well, fine. What is k then? K is a number that we call our constant of proportionality. Very fancy sounding, isn't it? Proportionality. All right. Let me show you how this works. If I have a ratio, 1/2, I'm going to call this x. And I say, well, 1/2 is equal to 2/4. And I'm going to call this other ratio y. What you need to think about is, all right, what did I multiply this by in order to get this 2 over here? And you multiply by 2. Same thing should hold true here, and it does. I multiplied by 2. This number then is your k value. That is your constant proportionality. In order to change one ratio, I multiplied it by this number, this constant, and I got this other ratio. So in other words, my y would be equal to 2 times that first ratio, x. This is useful in solving problems in tables. It's also good for making predictions. So we're going to, hopefully it'll make a little more sense as we go on. This sample here, I don't want you to actually write it down. Just kind of listen along to the problem. We have a frozen yogurt store, and the way that they charge their customers is by putting toppings. You put as many toppings as you want. You put your yogurt on a scale, and then you pay per ounce. So my question for you then is, does everyone pay the same amount per ounce? And when you're looking at that, you could think about the previous example. The previous example with that equation, this would be my x, and I'm multiplying by some number, k, to try and get this value y. And when you look at that, you go, well, that's not very helpful, though, because I don't know what I multiply 8 by to get 3.2. So you're wondering, is there another way that I could do this? Hopefully you realize that this is a unit rate question, just like the previous lesson, because I want to know the cost per ounce. So how do I do that? Well, if I'm spending $3.20 for 8 ounces, and then I take this and I divide it. Remember, 3.2 divided by 8, you would end up with 0.4, or 40 cents per ounce. If you check each one of these other ones, it should hold true as well. So if I took 2 divided by 5, you would see that it's 0.4. If you took 4 divided by 10, it's 0.4. 5 divided by 12.5, it's 0.4. It's always going to be 0.4. So what does this number represent then in that equation? Hopefully you realize that's the k value. That's the constant of proportionality. If I could take the number down here and divide by that to get this, then it would also work in reverse. I could take 5 and do the opposite, which is multiply by 0.4 to get that. Try it. 5 times 0.4 will give you $2. So in other words, if I were to set this up as an equation, the cost of my yogurt is going to be equal to this k value, the 40 cents, times how many ounces it is. So let's say my son, George, he takes a real long time putting his together. He's not up here in this table, and his weighs 15 ounces. So George is 15 ounces. Okay? How much do we have to pay for George's? Hopefully you say, all right, well, the cost is equal to 40 cents times however many ounces it is. For George, then we would pay, the total cost would be $6. When you have a table set up like this, and there is a constant of proportionality that is exactly the same for each part of the table, what we say is that the cost then is proportional to the weight, okay? Because there's a direct relationship between the weight and the cost. All right, let's move on, shall we? This is in the back of a cookbook. Again, what I want you to do for this one is I just want you to put this in your notes, that table right there, okay? I'm going to erase that. All right, so that's in your notes. Now, I'm going to tell you right up front that the ounces is proportional, okay? Proportional to the cups, okay? So you already know a proportion exists. What I want you to do is think about, all right, what is K in that equation that we gave you? In other words, what do you multiply every time to get the other number, okay? Pause the video, figure that out. Okay, you probably didn't actually try it, so I'm going to give you a hint. What do you multiply cups by to get ounces? Every time you multiply cups by something to get ounces. Now try it and see if you can figure out what K is. Pause the video. Okay, hopefully you say, hey, I realize that K is 8 because I take 2, I multiply by 8, and it gives me 16. There you go, so you know what it is. Can you put it into an equation then? That's my next question for you. So pause the video and try and write the equation. Okay, hopefully you wrote y is equal to 8x. Okay, where y is the ounces and x is the cups. So in other words, every time I want to find out, so if I have 1 here, I multiply by 8 and I get 8. Now the question I have for you next is, does it hold true for 0 cups? Does this equation work? And of course it does, because if you took 0 times 8, you still end up with 0, right? Cool. All right, last sample. This is a large word problem. Anytime that you have a word problem, you need to be able to pull out the key information. That is really critical. First of all, when you're finding key information in any math problem, any number as usual, almost always the numbers are going to be really important. So we have that, then we have this, 4 weeks, 112. And then what I always do is I go to the sentence with the question mark, and that tells you what you're solving for, so right here, okay? So now, if you actually read this problem, you find that there's a kid who's working for his parents, he wants to buy a video game system, that's 220 bucks, he works for 4 weeks, he earns this amount, and he's wondering, if I keep this up for the whole summer, will I have enough money to buy the video game? So he creates this table, and he starts using the table to figure out if he could do it. Well, I highlighted the key information here. What does the 220 represent? That's how much money he needs. So he needs $220 to buy his game system. The 4 weeks, $112. Okay, that is a ratio. So 4 weeks, $112. And then the sentence with the question mark, you want to know if he's going to have enough money. Well, do we have enough information? One of the things that we need to know is how long is summer, right? How long is summer? Luckily, that is answered by this table here, because we see there's 8 weeks down there. Otherwise, we might not be able to figure it out. We don't know how long his summer is. We don't know when he started. Another key thing in here, though, is right here. Earn money at this rate. Hopefully, you would realize that this right here is talking about a unit rate. He's earning a certain amount of money. It's the same amount of money per week. That's what he's saying. So 1 week I make this much, 2 weeks this much, on and on and on. Do you know what that represents in the y equals kx? Can you think about what that would represent, either the y or the k or the x? Hopefully you realize, hey, that's the k, because you're going to take the number of weeks worked multiplied by this rate or this money, and you're going to find out what the total earnings is. So the K is our unit rate here. It's how much he makes. I want you to try and fill out this table, okay? All right. The table, what you should have had is 0, 56, 84, 140, 168, 196, 224. All right? Now, the answer to the question, yeah, he'll have enough money at the end of the summer because he needs 220. At the end of 8 weeks, he'll make 224. The question is, how do you solve this? Okay? Now, there's a few different ways to solve it. One way, and this is something that I saw immediately, and maybe some of you did too, we say, well, if 4 weeks he earned $112, then here, to go here, I multiply by 2, and I get 8. So if I took 112, multiply by 2, I would get 224. That's one way to figure it out, okay? Some people don't like that. Another way is say, all right, well, what is the unit rate? Well, the unit rate is going to be right here. In 1 week, so he made $28 in 1 week. $28 in 1 week, okay? So in other words, in 8 weeks, so you could set that up then in an equation, and you could say that my Y value, which would be the earnings, is going to be equal to the $28, which is the K value, times the weeks. How many weeks did you work? Weeks. There. So that would be your X value. And that's another way to figure out. So you could say, all right, well, how much money would I make if I was $28 a week and I worked 8 weeks? And you say, oh, my total earnings would be $224. That's another way to solve it, okay? But here's a question for you. What would you do if the only information that you were given was this, and you were asked the same question? Now looking at it, you go, oh, well, it's not clear. I can't multiply to get over here to 8. And my unit rate, it's not given to me in the table because it's 3 weeks, so what could I do? Hopefully you say, I could find the unit rate. If I took $84 in 3 weeks, and I divided 84 by 3, I would find out how much I make in 1 week. $28 in 1 week. And then hopefully you realize that that is my K value. In other words, I took times 28 to get this. Once you have that, you could solve the rest of this table. All right? Goodbye, my friends. Goodbye.